Okay, there's basically two types of compound inequalities. There is an and then there is an or. Okay, so we're going to put our ands over here, and then I'm going to make a column over here for our ors. Now we're going to do the common and ones and the common or ones. We're not going to do any exceptions to the rules, because always, every time we teach you something in math, there's generally always an exception to the rule. All right. Now, the thing that you need to remember is that with your compound inequalities, if you see the word and, or it's in the form, which I'm going to show you, that what indicates that it's an and, your number lines are going to basically have some number on the left. All right, I'm just going to randomly make up a number here, maybe say -2. It'll have a number over here on the right. All right, you will have either open dots or closed dots, and that will be dependent upon the type of problem. So you might have like an open dot here and a closed dot on this end. You could have two closed ones, you could have two open ones. It just depends on the problem. But ands are always shaded in the middle. They're always shaded in the middle. So that's what your and looks like. All right, of course, unless there's an exception to the rule, but we're not going to do the exceptions to the rules today. Your or graphs, again, are going to have two numbers on them. All right, maybe say a 2 here and then maybe a 10 here. They don't have to be one positive, one negative. They could both be negative. They could both be positive. And again, you're going to either have open or closed dots. Okay, so this time maybe a closed dot over here and a closed dot here. But ors are shaded on the outside. So there's your distinction. Your ors are shaded on your outside. The and compound inequalities are shaded on the inside. So if you are working out an or problem and you don't shade on the outside, then you know you're doing it wrong. If you're working out an and problem and you're not shading in the middle, then you know you're doing it wrong. Okay? Now, they can be super, super simple, or they can be one-step equations, or two-step equations, or three-step equations, or four-step equations. All right, so let's suppose the most obvious and one, and would be the easiest. We're not going to work them out. I'm just going to show you what they look like. We could have something like an x is less than -3 and x is greater than or equal to -5. All right. If you see the word and in it, you know it's an and inequality, guaranteed. Over here, you're going to obviously see the word or. So you might see something like x is less than or equal to -3, or x is greater than 8. All right, so when they give you the problem and it actually has the word in it, you're not going to mess it up. Like if it's got the word or, you're going to know it's an or. If it's got the word and, you're going to know it's an and. All right, if it's got the word or, that's the only way you will ever see an or problem. The and problem, though, can be written a little bit differently. All right, now, when we do a number line, left to right, we read left to right. The numbers on the number line left to right, they should be getting bigger as we go to the right, right? -2 is smaller than 4. All right, so what I'm going to do is, what they're going to do is they're going to take the smallest number and put it first. All right, so out of a -3 and a -5, which one's the smallest? -5. -5 is the smallest. So the -5 is what they would write first. All right, now, this symbol right here, the point is greater than or equal to right now, but the pointy side is pointing to the -5. So if I want the pointy side here, then it's going to turn it into a less than or equal to, pointy side to the -5, pointy side to the -5. X is always going to be in the middle. All right, now my bigger number, which is the -3, I'm going to leave a little space here, -3. All right, now I'm going to take the symbol that's with the -3. In this case, the pointy side is pointing to the x. So do I need to flip it here? No. This is an and inequality. So I took this and wrote it exactly the way it should be, and you could see it like this. All right, so my point is, if they give you the and word in there, awesome, great, it's super easy, you know it's an and. If they give you something that looks like this, you also have to just memorize that's an and inequality as well. Okay, now these two symbols will always be less than or equal to, because I have to be able to take this and read left to right, and it makes sense. The smallest numbers will be on the left, the biggest numbers have to be on the right. So -5 is the smallest number that it could be. In the middle would be any number in between -5 and -3. So what, I could put -4 in there. Could I put -4.5 in there? -3.5, okay? And that's got to be less than -3, which would be the biggest number that it could be. Okay, so that's probably the hardest thing. These two right here, this one and this one, has to be less than or equal to. So I'm going to write less than or equal to. Those are the only two possibilities for those symbols. So if you're trying to write an and compound inequality and you're trying to put a greater than symbol in, you can't do it, because we read left to right. Our number line goes left to right, smallest to largest. Okay? Now, these are problems that you don't have to solve this. You don't have to solve this. You could immediately be given this and graph it. You could immediately be given this and graph it. You could immediately be given this and graph it. Okay? The next thing, step up, would be having one-step equations right here. We know how to do one-step equations. Or in its place, we could have two-step equations. Or it could have three-step equations. Okay, multi-step equations. All right, so that's your foundation on what you've got to be able to do here. So let's do real quickly a little one-step or. All right, it's probably going to say solve and graph. All right, let's say they give you x minus 3 is less than 10, or x plus 2 is greater than or equal to 10. This one may not work out. 13 less than 13. Let's make this an 18. Okay, now it's going to work. So, first, you got to solve it. Unfortunately, you got to solve two equations now for one problem. All right, you're going to look at the or. Am I going to shade on the inside or the outside? I'm going to shade on the outside. So, I don't know, think outside. I got a shade on the outside. All right, now I've got two equations I have to solve. When I solve this one, what am I going to do? I'm going to plus 3, and I'm going to plus 3. Going to cross out there. I'm going to have x is less than 13. All right, now on this one, what am I going to do to solve this one? I'm going to subtract 2. I'm going to have x is greater than or equal to 16. And I'm going to have an or in here. Okay, now that's my answer. That is the answer to the solve part. Now we're going to graph it. And we're going to cross our fingers and hope this works. I think it does. What two numbers go on the number line? 13 and 16. So I'm going to do 13. I'm going to do 16. On the 13, what kind of dot am I going to have? Is it going to be open or closed? Open. Why? Why? Yeah, it doesn't have the equal to part. So I'm going to have an open one there. All right, this says x is less than 13. Where are the numbers that are less than 13? To the right or to the left? To the left. And does that fit our, we got a shade on the outside? Yep, it fits. So then I'm going to shade the outside. Okay, now over here on my 16, am I going to need an open dot or a closed dot? Closed dot because it's got the equal to part. All right, x is greater than 16, so am I going to shade to the right or to the left? To the right. Does that make sense for my or shading on the outside? Yes. So there's my graph. These are compound inequalities. So this is my solve part or my answer, and then this is my graph. So they may say solve and graph. If they say solve, and that's all they say, then you just have to solve and you stop right there. But if it says solve and graph, you do the math, you solve, and then you put it on the number line. Okay, did you do this last year? No, I didn't think so. Okay, so, and that's okay. Now, can we do it with a two-step equation instead of one-step equations? Could we do it with multi-step equations, distributive property, combining like terms? So these could be as complicated as we needed them to be. All right, and we're still going to do it like this. All right, so let's do a two-step equation. And let's do a solve and a graph. And let's make this one an and. So let's make this negative 20 less than or equal to 3x minus 2. Let's say they actually use the word and then they do a 3x minus a 2 is less than 1. Okay, so it's an and. All right, so on the ands, where do we shade on ands? We shade on the inside. Okay, so when we get done working this out, it needs to work out so that we're shading on the inside. So I'm going to put a little inside there just to remind us that that's what should happen. Okay, two-step equation over here. What's the first thing I'm going to do? Plus 2. Yep, I heard someone say plus 2. So I'm going to plus 2 and I'm going to plus 2. We had to be really good at these one-step and two-step equations at this point. All right, negative 20 plus 2 is going to give me a negative 18. Less than or equal to 3x. All right, so I'm going to divide both sides by 3. Do I have to flip it?
No.
No. Yeah, I just asked that question just to see. I'm dividing by a positive number. Remember that rule we learned like last week? If it's negative, if the 3 was negative, we would have flipped the inequality symbol, but we don't have to flip on this one because it's not negative. All right, so then that's a negative 6 here, greater than or equal to an x. Okay, now we've got an and, because you always write the word in between them. All right, now let's do this. This is a two-step equation, so my first step is going to be a plus 2 and a plus 2. Minus 2 plus 2 is going to go away. I'm going to bring that 3x down. I'm going to have the little less than symbol. 1 plus 2 is going to give me a 3 on this side. Divide both sides by 3. I'm going to have x is less than 1. Okay, so now technically that's the right answer. All right, that is the right answer. However, what if you're doing a multiple choice question and that's not the choice? If you're doing a multiple choice thing and they don't have it written like that, the other way they're going to write it is they're going to put it together with x in the middle. All right, so we're going to write it in a compound way. So of these two numbers, which one is smallest? The negative 6. So I'm going to write negative 6 first. We're going to write this left to right, smallest to largest. So I'm going to pick the smallest number and I'm going to put it here. Okay, now I'm going to come over here and I'm going to look. All right, I've got an inequality symbol to it. The pointy side is to the negative 6. It's a less than, and it has to be less than or equal to. This is less than or equal to, so I'm going to write it exactly as I see it, less than or equal to. What do I always put in the middle? An x when we're trying to write it as a compound inequality. All right, now that means the 1 has got to go over here. All right, now this one was kind of easy because this says x is less than 1. I'm supposed to have less than or equal to. Pointy side is to the x. So when I put a less than in, then I've got less than or equal to. I have these two numbers in the appropriate order, smallest to largest. This is also the answer. So what I'm trying to get at is you may see a problem like this, You're going to work it out. You're going to work it out. You'll have the word and in between it. But if it's a multiple choice test, this may not be the answer. This is what you may see. Okay? So either one of those would be the solve part. Okay? Now, let's graph. Okay, what number goes on the left? The -6, because I got to have the smallest one on there. What number goes on the right side? The 1. Okay, we're going to come up here to the -6. What kind of dot am I going to put on? I'm going to put a closed dot. What kind of dot goes on the 1? Open. I'm looking at these symbols. Sorry. I'm looking at these symbols right here that are sitting closest to it. If it's got the equal to part, like we've been doing for the last couple of weeks, it's solid. If it doesn't have the equal to part, it's open. And ands are shaded on the middle. All right, but can we look at this? This says x is less than 1. If I say x is less than 1, I'm going to shade to the left. And then this one, -6 is less than x. What numbers would go in here to make a positive? It would have to be something that is bigger, which would be shading to the right. So then, yes, I am shading in the middle. So my ands look like this. So the graph looks like this. So you got to be able to graph in between these. Okay. Now, I wrote this problem with the word and in between it. They don't have to. They can give you something that looks like this, and then you just have to know it's an and. All right, you just have to know it's an and. So let's do one of those. And we'll do it as a one-step as opposed to a two-step or a multi-step. All right, so again on this, let's suppose they said solve. Let's do just solve on this one and not do graph because I want to show you the difference. Sometimes it's going to say solve. Sometimes it's going to say solve and graph. So let's say it says solve and they give you -4 is less than x minus 5 less than or equal to -1. So this form, compound inequality, you just have to know it's an and inequality. So, and inequality. So if it's in your notes, then you're going to be able to remember this. And so ands we shade on the center if we were going to shade, but we're not going to graph on this. We're just going to solve. Now, I think the easiest way to do this is to use how we solve equations and just keep that same concept for this. When we solve equations, what are you trying to do? You try to get x on one side of the equation by itself, right? But I don't have a side. I don't have a left side and a right side. But what I do have is I have 3 parts. I have this section. I have the section in the middle, and then I have the section on the right. I've got 3 parts. So if I've got an x right here, and we know we do inverse operations, I got to get rid of whatever's in the middle so that the x is by itself in the middle. What's the opposite of subtracting 5? Adding 5. So that's not going to change. We're going to do that the exact same way we always have, except you're not just going to do it on the left side and the right side because I don't have a left or right side. I have a middle, I have a right-hand side, and I have a left-hand side. So it works just like solving an equation, except instead of just doing it on 2 places, you have to do it on 3 because we have 3 sections. Now, what's -5 plus 5? Crosses out, 0. That's exactly what we want to happen. Okay, and then if these 2 things cross out, what's the only thing I have left in the middle? An x. All right. I'm not going to do anything with that less than or equal to sign. It's going to come straight down. I'm not going to do anything with this less than sign. It's going to come straight down. Can I do the math over here? What's a -1 plus 5? It's going to be a 4. Can I do the math over here? -4 plus 5? 1. And now I'm down to this, and I have just solved that problem. That's my solve answer. That's my solve. I solved it. That's my answer. So you just got to do it in 3 places as opposed to 2. I could even do 2-step equations like that. Let's do one more. Let's do another one, and let's just focus on the solve. Let's suppose I had a -20 less than or equal to a 3x minus a 2 and then less than 1. Okay, it's written as a compound inequality because it's got the 3 sections and I got less than, or equals to. I know this is an and inequality, and it's called a compound inequality. Okay, now, if I always start in here in the middle where the x is, how many steps am I going to have to do to isolate my x? Shayla? Yeah, I'm going to have to do 2. I'm going to have to add 2. I'm going to have to divide by 3. Okay, just like we always do on 2-step equations. We always do add or subtract first. We do multiply or divide second. Okay, so let's add 2. How many places do I have to add 2? I have to add a 2 here. Then I also have to add it on the other 2 sides. So I got to add it on the right side. I got it added on the left side. So you just got to do it in 3 places as opposed to just 2 for your equations. All right, now in the middle, when I crossed out these 2's, what's left in the middle this time? A 3x is left in the middle, and that's okay. I'm going to bring down that less than inequality that's on the right. Not going to do anything with it. I'm going to bring down the less than or equal to that's on this side. And then I'm just going to do some math here. 1 plus 2, 3. Negative 20 plus 2, negative 18. And then I know I'm not done yet because my x is not isolated. It was a 2-stepper. I got that 3 that's sitting there. I got to get rid of the 3. So now that says 3 times x. What's the opposite of multiplying by x? Yep, divide by 3 on all the sides. So you got to do it in the middle. You got to do it on the right-hand side. You got to do it on the left-hand side. So the 3's cross out just like they always do. Negative 18 divided by 3? Negative 6, less than or equal to the x less than 1. And then that's your answer. So the ands, there's a little bit more work to the ands. The ors are pretty straightforward. If it is an or problem, it will always have the word or in it. If it is an and problem, it can have the word and, but it also can be written like this. Okay, so do we think we can do this? Okay, it is brand new. That's okay. When we do the formative, I want you to definitely have your notes out. If you need